Hi friends, in this class we are going to know how to find the equivalence resistance of a given circuit. If a circuit has more resistance, it means less current is flowing through it. Equivalence resistance is a different way of indicating total resistance which we calculate differently for series and parallel circuits. Now we take two different examples and try to solve. First one, the circuit is given here. In this circuit, we need to find out equivalence resistance between the points A and B. To do this, we need to start from this point, that is midpoint of the circuit. This is the midpoint of this circuit, and here we have four resistances, that is 3 ohms, 4 ohms, 3 ohms and 10 ohms. If you observe carefully, these three resistances, 3 ohms, 4 ohms and 3 ohms, these three resistances are in series combination. If resistors are in series combination, the equivalence resistance will be find out by this formula. So R equivalence is equals to R1 plus R2 plus R3. As we have three resistances in series, we use this formula. Let us try to find out. R1 is 3 ohms here and R2 is 4 ohms here and R3 is 3 ohms again. Sum of all these 10 ohms. Now the circuit will change like this. The point A and this is the point B, and this resistance will remain same like before, and this resistance also remains same as before, and this will also be same as before. This will also be same as before, and this resistance is 15 ohms, and this is of 5 ohms, and this is of 5 ohms, and this is of 10 ohms. And now this part will change like this. And the resistance of this is 10 ohms. And now if you observe carefully, these two resistances are in parallel, that means 10 ohms and 10 ohms. These two resistances are in parallel combination. Let us try to find out the equivalence resistance of this part. And we know the formula to find the equivalence resistance in parallel connection is 1 upon R equivalence is equals to 1 upon R1 plus 1 upon R2. As we have only two resistances here, we take only two, that is R1 and R2. Let us try to substitute the values. That is 1 by 10 plus 1 by 10. So this is, let us try to find out the total value. That is, as we calculate this one, we get 2 by 10, that is 1 by 5. And this is the reciprocal of, as or equivalence is 1 by 5 ohms. This means R equivalence becomes 5 ohms. So the circuit again changes like this. This is the point A and this is the point B. This resistance remains the same as before, and this resistance also remains the same as before, and this resistance also same as before, and this value becomes 5 ohms. So this is 15 ohms and this is 5 ohms as before. And this is also 5 ohms as before, and this part will become 5 ohms. So the circuit will change like this. And now we need to find out the equivalence resistance of this part. If you observe carefully, these three resistors are in series combination, and let us try to find out. So R equivalence is equals to R1 plus R2 plus R3. Substitute the values. 5 ohms plus R2 5 ohms plus R3 again 5 ohms. So the total value becomes 15 ohms. Now the circuit will change like this. This is point A and this is point B. Now this resistance will remain as before, and now this part, this total value becomes 5 ohms, that is like this. So these are the circuit will change like this, and this value is 5 ohms and this value has become 15 ohms. And now if you observe carefully, these two resistances are in parallel connection. We know the formula to find the parallel connection. It is 1 by R equivalence is equals to 1 by R1 plus 1 by R2. Substitute the values. 1 by 15 plus 1 by 15, so that is 2 by 15. 2 by 15, this is 1 by or equivalence, and we need or equivalence. So or equivalence is equals to 15 by 2, that is equals to 7.5 ohms. So like this we can find the equivalence of any given circuit.